This lesson is obviously on proportions, multi-step, and solving similar figures. You are expected to take notes, so if you don't have your materials handy, pause the video and get those out now. Okay, I'm going to go through this rather quickly. If at any time I'm going too fast for you, please remember you can always pause this video to take notes or go back. Okay, normally you would use means and extremes to solve proportions, right? You would do 30x equals 5 times 12, 60, and then you solve for x by dividing both sides by 30. X would equal 2. We are going to use the same steps to solve for multi-step proportions. This is what a multi-step proportion might look like. One thing to keep in mind here, the x plus 2 on the top of the first ratio, that is one quantity. So you might want to put parentheses around that, and then that should look really familiar as a distributing problem. You have 4 times the entire quantity of x plus 2 should all be equal to 24. This is a pretty easy equation considering what we've done so far this year. You distribute your 4, subtract your 8 from both sides. I'm running out of room, so you will say that 4x equals 24 minus 8. Over here is 16. Divide both sides by 4. X equals 4. Okay. So again, the steps are no different. You write your means and extremes as an equation. That is what I did right there. This is my equation before distributing. Some of you are going to want to skip that step and distribute in your head. I will caution you against that. Showing all of your work, and then we just solve the equation. Now, here's a different sort of looking proportion. You would start your means and extremes as an equation. So, what is 6 times 5x? Hopefully you remember how to do that. You would just multiply the numbers. You multiply the 6 times the numerical coefficient, which is 5, which results in 30 times x. And then 2 times 5 equals 10. Now don't freak out. It's not going to work out perfectly, and we've already worked with fractions and equations, so we know that that's okay. When we have something like this, we don't actually divide. We're not going to write a repeating decimal for this one. We are just going to simplify by dividing both top and bottom by 10, which looks like that, and leave the division problem in fraction form. Here's example number 2. I want you to pause the video and try to work that out for yourself. And when you come back, we'll work through the answer together. Let's see how you did. Now, I've erased the work from the other problems so it doesn't get in our way, and I've written our means and extremes as an equation. You have to distribute your 7. Add 49 to both sides. Whoop. And divide both sides by 7. So for this one, x equals 11. Okay, I'm going to expose a couple more problems for you to work on. And you're going to copy the problems, work through them. You can pause the video to wait for the answers before we move on. Now, these both have double sides. Just remember, this is one quantity. Oh, that didn't work out so well. Parentheses around both. Same with this. Okay, I'd pause the video now, and when you come back, we'll see what you got. All right, let's work through those together. Hopefully you already have a solution to both of these problems. When I do my means and extremes, I have 7 times the quantity, x plus 9. That should be equal to 8 times all of that stuff, x minus 2. Distribute. Okay, so over here, simply because I don't want a negative, it doesn't really matter which way I go. I get 1x. I'm going to add 16 to the other side. Okay. So if I plug 79 back in here, let's make sure that works. What is 79 plus 9? Hopefully you got 88 divided by 8, which equals 11. And 79 minus 2, that would be 77 over 7, which is 11. So we have proved that these definitely are proportionate. We've checked our work by plugging our answer back in, and x equals 79. Okay, the second problem should work exactly the same. If by chance you didn't do both of these, pause the video and work through that second one now. Okay. When you distribute, you have 4 times 7. Actually, I like that different. Should be equal to 6 times x plus 1. And some students ask, does it matter which one goes on which side? Should I have done the x times, or I'm sorry, the 6 times x plus 1 first? It really doesn't matter because you have all of this stuff over here on one side and all of this stuff over here on the other. So it really doesn't matter which one you use first. And distribute. Again, I'm going to move my 4x over so I don't have to deal with a negative coefficient. If I had one, it's not a big deal. X equals 11. Oops, it's an equal sign. So let's check it and find out. Let's come back over here. If I put in an 11 where x is, on this side over here, I end up with 4, 12, which reduces to 1/3. And over here, I get 6 over 18, which also reduces to 1/3. Those are indeed a proportion. Okay? You'll see problems like this to practice tonight on your homework. Let's talk about using proportions to solve similar figures. I think we've done some of these, but it's always good to review the process. These items are the same shape, but not necessarily the same size. And we have to indicate and figure out that 2 figures are indeed similar. Corresponding parts. That's very fancy for the sides or angles that have the same relative position. What do I mean by the same relative position? Well, they're kind of in the same place, but on the different figure. So if I'm talking about this line segment right here, line segment AB, Ooh, that would correspond with which side on this second figure? This one. It's line segment HI. Hi. Okay. Also, if I was talking about this one here, line segment AC corresponds with that one. That's what I mean by the same relative position. This is like the tall guy on the side over here. This is the bottom or the base of this triangle in this instance. And this is the base, goes with this. These should be kind of equal to each other. Well, not equal. I shouldn't write equal. They correspond with each other. Okay? So what does that have to do with anything else? Also, your hypotenuse, BC, goes with IJ, line segment IJ or JI. These two kind of go together as well. So, how's that deal with what we're doing in math? How does that add up? Well, if I wanted to set up a proportion, I would think, okay, well, I'm talking about this guy here. AB relates to IHI. Sorry. And that should be equal to the relationship between line segment AC and HJ, which should also be equal to the relationship, the ratio of line segment BC to IJ. If there's a missing value for any of these, you can solve it. And I'm just going to make some numbers up. Is 8. Say this is 4 and that's 12. If this was 16, you could very easily see the relationship right there. I know, which is why I'm using those numbers. But if this was X, then that was Y, certainly you'd be able to solve this in your head, again, because we know the relationship is really backwards. This should be the smaller of the two. Let me put a disclaimer here. Drawn to scale. Okay, so clearly with this side being 8 and this being 16, they're not drawn to scale right there. So anyway, getting back to the numbers, if I needed to solve for X and Y, I can set up relationships using sort of these ideas. So I take line segment AB, and I know that is, and that corresponds with line segment HI, and that is 16. Okay, now if I were to put figure 1 on the top, figure 1 should be the top number on my second ratio as well. And so we're solving for X. X corresponds with line segment AC, which is 4. Now I use my means and extremes to solve. I believe that's 64. That's 8x. X equals 8. So this side is 8. Now I need to solve for y. Do the same. In fact, look, you have this set up. So let's just use that again. There's a hint not to let rotation fool you. I'm out of room, so we'll ignore that for a second. So now I have, can you erase some of this? Give me some more room here. We already have, well, nope. Didn't realize I tapped that. We have 8. Oh, wow. All right. 8 to 16. Now we know that this 90 guy, the hypotenuse 12, corresponds with the side y, same relative position, the hypotenuse. That corresponding same relative position is going to come in handy when we start working with angles in geometry. So since I used figure 1 on top, I need to put the 12, because that's from figure 1, on top. And my y goes here. So now you're going to use your cross products to solve. And why don't you pause the video really quickly and try to solve that. Okay, so hopefully you did your cross products and you got 16 times 12 is 100, and 92 equals 8. Divide both sides by 8. 8 goes into 19 twice. Of, oops, 3, not 1, sorry. Lost my train of thought. Y is 24. And that makes sense. All of those numbers make sense because you know basically from figure 1 to figure 2, all the sides are doubled. So if I double 8, if I double 8, I should get 16. If I double 4, I should get 8. And if I double 12, I should get 24. So all of those check out. Again, my warning down here, don't let rotation fool you. Okay, if you have a 90-degree corner, those line up. So take a look at these. Again, this will be easy to figure out the sides. What side corresponds with AC? We'll call AC the base in this particular triangle. Which side on the other triangle corresponds with that? Hopefully you chose FD. Okay, so we know that, once again, everything is doubled. 12 to 24. And so now you got to figure out, but what does BC correspond to? And what does AB correspond to? Because one of these sides is 10 and the other one isn't. So which one goes with which? We have to figure out what the actual flip is here. And we know this is the base. So what you do is in your mind, you put this side on the bottom. So when you take a look at this figure, if this was on the bottom, FE, this, and this becomes ED. They're so not drawn to scale. So ED would correspond with BC. This would be the side that's 10. This would be the side that's 14. Again, these numbers are very easy to work with. I'm showing you them with easy numbers just so you can get the point of it all. If you had to solve for X, if I set one of these up for the unknown, you could solve both. Okay. And again, this is what it would look like. Obviously, if the numbers are this easy, you don't have to set up a proper proportion. You can solve it using mental math and your basic number skills. Okay. Hopefully you took some good notes on this. If you have any questions, we'll start there first thing tomorrow. Good luck.